Accumulator basics. Objectives. Describe the function of an accumulator. Contrast bladder and piston style accumulators. List the typical uses of an accumulator. Define the terms charge and pre-charge. What is an accumulator? An accumulator is a device that allows a hydraulic system to store oil, under pressure, for an extended period of time. Terms. Pre-charge. The pressurized gas in the accumulator. Charge. The hydraulic fluid in the accumulator.
Accumulators come in two basic types: bladder types, piston types. What are accumulators used for? Energy recovery. Absorb system shocks. Dampen minor fluctuations in system pressure or flow. Provide supplementary flow, for example if the pump is undersized. Maintain system pressure. Store energy, emergency power, in the form of fluid under pressure. Noise elimination. Absorption of thermal expansion. Leak compensation. Compensation for slow pump control or response. Advantages and shortcomings. Each type of accumulator has its own advantages, and a few shortcomings. Bladder type. Advantages. Very responsive to system demands. Pre-charge gas seldom needs maintaining/topping up. Generally less expensive than piston accumulators. Lighter in weight than the equivalent-sized piston model. Shortcomings. Bladder may become brittle and burst. Compressing the bladder too much can damage it. Cannot be fully discharged too frequently without causing damage. Piston type. Advantages. Require less frequent repair. Can be fully discharged frequently without causing damage. Shortcomings. Slower to respond to shocks. Requires more frequent checks of the pre-charge pressure due to internal leakage around the piston seal. Heavier than the equivalent-sized bladder model. The bladder type accumulator. Let's take a closer look at the inner workings of an accumulator, starting with the bladder type. A bladder type accumulator, sometimes known as a hydropneumatic accumulator, is a metal tank that contains a rubber bladder filled with compressed gas. There is also a poppet valve in the discharge port and a gas valve used to pre-charge the bladder. As the bladder is being pre-charged, it will expand to the point of forcing the poppet closed. The poppet is there to ensure that the bladder can expand out into the discharge port. Minimum system pressure. That way the bladder doesn't expand enough to close the poppet during normal operation. Accumulators are pre-charged with dry, inert, nitrogen gas rather than simply using compressed air. Why? Because if the oil and oxygen in the compressed air were to mix, it could start a fire, or even explode. Possible when the hydraulic system pressure is greater than the gas pre-charge pressure. The incoming oil compresses the bladder and the gas. This compression in turn increases the pressure of the pre-charge gas. When the hydraulic system pressure decreases, the bladder expands again, forcing the oil back out. It is this constant seeking of equilibrium between the pressure of the hydraulic oil and the pressure of the pre-charge gas that drives the function of the bladder-style accumulator. Advantages of the bladder-type accumulator. The bladder is made of a light and flexible synthetic rubber, which means there is virtually no resistance to movement. Because of this, a bladder-type accumulator can respond nearly instantaneously to changes in the hydraulic system. Bladder-type failure. The rubber bladder, which allows the bladder-type accumulator to respond so quickly, top pressure changes, is also the greatest point of failure. Because the bladder is made of rubber, it is vulnerable to cold environments. Extended periods of time in the cold can cause the bladder to become brittle, and a brittle bladder is prone to bursting. An incorrectly set pre-charge will cause no end of system function problems, and a few maintenance issues as well. Here are a few examples. If the pre-charge is too high, the bladder will be forced against the poppet during normal operation. This can damage the poppet or cause the poppet to cut into the bladder. On the other hand, if the pre-charge is too low, the bladder will be crushed into the top of the accumulator. Just like popping a balloon with a pin, any cut or puncture of the bladder will cause immediate, catastrophic failure. Plus, there is no way to test that a bladder is reaching the point of failure before it does. Because of this, bladder-style accumulators are best used in applications where the sudden loss of hydraulic pressure would not endanger lives. The piston-type accumulator. Now let's have a look at the inner workings of the piston-type accumulator. A piston-type accumulator does away with the gas-filled bladder. Instead, there is a sealed piston that separates the gas-filled side of the accumulator from the oil-filled side. When the accumulator is being pre-charged, the piston rests at the bottom of the casing. When the pre-charge is set correctly for a given hydraulic application, the piston will not come in contact with either end of the accumulator. As the pressure in the hydraulic system increases and oil is forced into the accumulator, the piston rises. The rising piston compresses the pre-charged gas, stopping once the pressure of the compressed gas is equal to the pressure of the hydraulic oil. When the hydraulic system pressure decreases, the compressed gas pushes the piston toward the outlet port. This, in turn, forces oil back out of the accumulator. Advantages of the piston-type accumulator. Piston-type accumulators have several advantages over other designs. Because of their simple design, piston accumulators are more durable and require less maintenance. The piston accumulator will not be damaged if there is an unexpectedly high pressure spike or if it is fully discharged in a single instance. There may be an alarming noise of the piston colliding with the top or the bottom of the vessel. If this noise occurs frequently, the gas pre-charge may have to be checked. Piston cylinders tend to fail slowly. Because of this, they are more suitable for applications where the sudden failure of the accumulator would endanger lives. Piston-type failure. Even though the piston-type accumulator is more durable, that doesn't mean it is invincible. The piston seals or even the piston itself. If, on the other hand, the pre-charge is set too low, the piston will force to the end of the accumulator and remain there. As far as the hydraulic system is concerned, the accumulator now serves no purpose. The primary weakness in a piston accumulator is the wear that occurs on the piston seal. Over many cycles of the accumulator, small amounts of hydraulic fluid are able to slip past a worn seal, crossing into the pre-charge side. As the amount of hydraulic fluid on the pre-charge side increases, the pressure on the pre-charge side creeps up and the travel range for the piston decreases. As the amount of hydraulic fluid on the pre-charge side increases, the pressure on the pre-charge side creeps up and the travel range for the piston decreases. This means the accumulator is able to accept and discharge less hydraulic fluid at the same time as the system pressure needed to move the piston is increased. Eventually the pressure on the pre-charge side will be equal to the maximum system pressure, and the piston will not move from the base of the accumulator.
It is also quite possible and common with some piston seals that, as wear occurs, the pre-charge gas may leak past the piston into the hydraulic oil, resulting in a decreased pre-charge.
Failure detection. There are a couple of different ways that failure is detected in piston-type accumulators. One way is to use a pressure gauge or a transducer to detect the pressure on the gas side of the accumulator. This allows us to detect any increase of the pre-charge pressure. Another technique is to have a piston position sensor added to the accumulator. Tracking the position of the piston can determine if it is in the expected position for a given system pressure. Deviations from the expected position act as a warning that the pre-charge pressure has changed.